So now we're going to look at the control volume 1, 2, which is for the turbine. Again, it's at steady state, so the change in energy is 0. The heat transfer is 0 because it's insulated turbine. Then we have the work, and then the change in entropy times the m dot here. Looking at it here, so this is 0 minus the work. This was mistaken, shouldn't be here, so just ignore those. Times the change in entropy over here, the mass flow rate times the change in entropy. So then we know the work here, but then we don't know what H1 and H2 are. So back to our PV diagram. We know the X value here, so we know it's very close to fully vapor phase, but not quite. We know the pressure, so then we can approximate the temperature using the tables in the back of the book. Here, so we go through, this is an equation to find out what the specific volume is here. So then we plug in all of our numbers, and we get our specific volume and our entropy. This is the guy that we really wanted though, because this was a mistake, so I don't know why I explained that. But so we have the entropy here, and then we find the numbers from the back of the book, and we plug them in. Then we want to look at the work here. So we have our mass flow rate. This is getting ignored, and this is getting ignored. So really we're just multiplying it by this here. So this is the entropy going into the system, and this is the entropy leaving the system. So this is the work that the turbine produces, the useful energy that is produced by the turbine and therefore by the entire power plant. And just so you know, this megawatt here, it actually has a unit of kilojoules per second. So this is how many kilojoules are being produced per second. Well, in this case it's actually megajoules per second.